Hello everyone, thank you so much for tuning in. My name is Samer, and in today's video, I'm going to walk you through a real-world web scraping / data cleaning project. So the data that we'll be dealing with today is data from the NFL. It's statistics particularly pertaining to Tom Brady, who's had a wonderful 22 years in the NFL, and that gives us a lot of data to work with. Plus, there are rumors about his retirement, so I thought it was an exciting time to look back at his career, regardless of whether he retires or not this season. So I will be working primarily with the Pro Reference football website. Now, do keep in mind that you don't want to clutter their website with too many web scraping requests. That can really clutter their websites. For our case, we are just going to be working off of this page, which contains two tables. It contains a data table about his regular season, and then another data table including the playoff information. So a part of why I wanted to show this example is because I'm interested in this data, but I thought this would demonstrate a perfect example of how web scraping can be pretty problematic and where you have to go through a couple of loopholes to get some clean data scraped. So we won't be working with Selenium in this case. We don't need it. We'll just be working with Rvest, a package that is able to parse the HTML content and be able to scrape the data from those HTML elements. So we won't need to necessarily use Selenium because we're only navigating one website, and actually Rvest works really well in extracting HTML tables. But there are some struggles and there are some loopholes in scraping this data. So we're going to walk through it today because this is something that you can face in the real world. Do keep in mind that I'm using this for educational purposes. I'm just scraping a little bit of data from this website. I'm just scraping data particularly regarding Tom Brady, and I'm going to use that for a possible analysis in the future. But I just wanted to use this as an example, just for educational purposes, to show you the struggles of web scraping that you can face potentially. So we'll be walking through it, and I think this is going to be a very insightful tutorial for you. We'll be working primarily in R, so if you're a fan of R, this video would be really great for you. Okay, so we have that website, and first of all, we need to import the necessary packages. So in this case, we are only going to need two packages for this. We will need the tidyverse. So the tidyverse is a collection of packages that will allow us to do data cleaning, data manipulation, and even data visualization, although we will not need the data visualization part for this tutorial. And the second package we will be needing is the Rvest package. The Rvest package, like I said, is the package that allows you to parse the HTML content and extract the HTML elements from it. So first things first is you want to obviously feed it in the URL of the website. So we're going to go ahead and get it. So here is the website, and this is the only website that we need to get to. So we're just going to create a URL object and store our URL. So let's go ahead and run these. Great. Now we're going to go ahead, and now we have to load in the HTML content of it. So in order to do that, we just want to load HTML content. And we want to call this page, and page is going to equal to URL, and we're going to pipe in the read HTML function. And simply put, the read HTML function takes the URL and then it parses the HTML content. So we're going to go ahead and load it and run it. And if you look at the page object, you're going to see that it has HTML inside of it. It's an HTML document. And now we just need to, you can do other things. You can extract elements, you can extract tables, you can extract text. So we'll walk through that also. So now we have two tables on our website. We have the regular season table and we have the playoffs table. So how do we go ahead and identify a table? So from the last tutorial, we used the inspect function a lot. So we're going to use that as well. We click on inspect, and you can click on any element in the table. And then you want to get to where there is a table tag. So there's the table tag right there. And generally speaking, you want to use the CSS selector. You can also use the XPath for when you want to find an element using Rvest, but we can use the CSS selector. And the best way to identify it is usually it's going to be the ID preceded with a pound sign. Or what you can do is you can right click here and you can copy selector. And if we were to paste it, so let's say we paste it here, it's going to be pound sign stats. So that's what we're going to need to get the table. So let's get stats regular season table, and we're just going to call this stats equals to, we're going to pass in the page function, which is our HTML object. Then we're going to pass in the HTML element function, and we're going to use the CSS parameter, and we're going to set that equal to our CSS selector for the table. And last but not least, we are going to pass in the HTML table function, which will basically scrape the HTML table from the HTML content, and it will return a nicely formatted table. So if we were to run this portion of the code, we can see that things have been loaded in very nicely. So we'll go ahead and we'll store it in the stats object. We can go ahead and do the same for the other table, which is the playoff table. So we'll go and scroll down. Here's the playoff table. Let's go ahead and inspect an element. And if we go into the table class, we can see that the ID is stats_playoffs. So we can assume that the CSS selector is going to be #stats_playoffs. So let's go ahead and do that. So we'll do stats playoffs. And then we're just going to take this code and we are just going to make one small change to it, which is right here. And we're just going to put _playoffs. And we do want to obviously set this equal to. And if we were to run that, we have another stats playoff with also another table. Cool. Now let's go ahead and see if these tables are the same. We can figure that out by looking at the columns. We can kind of use that as a starting point. So if we look at the number of columns for the stats table, we need to close that, of course. And if we set that equal, we have 51 columns. And if we look at the number of columns for the stats playoffs, we can see that it has 44. So obviously there's a difference in columns, and we will get to that later in the tutorial as to how to deal with that. Alrighty, so now this is the stats playoff, so we also get stats playoffs table, so that's the code for it. Okay, so now we'll start with the data cleaning. So now we are ready to jump into the data cleaning, and there are a couple of observations that we need to make. So let's go ahead and look at the stats table first. One of the biggest problems we see is that the headers are missing, and then it has some partial headers in the top, but then it seems that all the headers are in the first row. If we look back at the original table, and let's close out of the inspect, and let's scroll all the way up, we can see that the passing, rushing, receiving, and scoring is like a header, and then we have a subheader which includes all the sub-elements of the headers. So for example, the yards in here includes the yards gained by passing, and then the yards over here includes the yards lost due to sacks. So this is a heading, and then this is a subheading, and it becomes a little bit complicated when we want to deal with this. Because if we were to just set the column names equal to the first row, then what is going to happen is it's going to result in multiple instances of yards being mentioned. Because this is passing yards, and then you have another passing yards, and then you have rushing yards. So you need to differentiate between them. One way we could deal with that is to kind of create combine the column headers and the first row together to create like some type of unique column names. So I'll show you how to do that. So first of all, we want to go in and we want to obviously we want to change the name of the columns. So we say columns, call name stats, and we're going to set that equal to paste. And what we're going to paste here is we're going to take in the call names of the stats. And what we want to do with it is we want to concatenate it with the first row. So stats, and we want to take the first row, which is 1, and we want to separate it using an underscore. So separator equals to underscore. And then what we want to do also is we want to remove all the instances where it starts with an underscore. So, and I'll show you what that means in a second. Well, actually, let me just run this by itself without the str remove all, just to show you the results of that. So if we were to run this, for example, what happens here is just to demonstrate. So in this instance, what will happen is for this column, for example, right here, which is column 12, its name is going to be CMP underscore passing. And the second one is going to be ATT, or sorry, it's going to be passing underscore CMP because we're starting with the column name and then we're pasting the first row. So it's going to be passing underscore CMP. And then the second one is going to be passing underscore ATT. So if we were to run that, we can look at the data and we can see that we have that passing CMP, passing ATT. So we can see that now. So that creates some type of unique columns and creates some type of differentiation between the columns, which is important. But the thing here is we have these columns that start with an underscore, and we want to get rid of that. So in addition to that, what we want to do is we also want to remove we want to be able to remove the column name. So we want to say we remove the underscore from the column names. So we want to do sc remove all, and we want to pass in the call names stats. And what we want to remove is just the beginning of the underscore. And that's it. And if we were to run that and we look back at the stats, we get a much cleaner heading over here. Good. We fixed the problem with the heading. So now let's go ahead and take care of some other stuff. So what we've noticed here is if we look through the data, the first row is redundant, but also if you look into the data, since all the seasons are stacked together, whenever the data for the new season is, you're going to see a new header, and then you're going to see the data. So this gets in the way of us collecting that clean data. So one of the patterns we realize here is that in the date column, wherever there is text, alphabets, we can remove those rows entirely because those are the rows that we do not need. So what we could do is we can say, remove unnecessary rows. And what we're going to do here is we are going to remove the characters over here. So this is very important. So we're going to say stats, and we're going to set that equal to stats. And we're going to use the grepl function, and we are going to detect to where it starts with a bunch of characters, which include an A to Z, and then also has a bunch of other characters as well, but I don't think we need to put these extra stuff. As long as you have the alphabets in there, that's the important part. And that's what we want to remove essentially. And we want to say stats date. Okay. So what this does, the grepl function will detect for this pattern in the stats date column. So if we were to run the grepl, we're going to look at that and select run. So it's going to return a bunch of falses and trues. So if it's true, what that means is that specific cell, so for example, row number 18 in the column of date means that it does include text in that row. So that's a good way of detecting string patterns. The exclamation mark means do the opposite. So in this case, we're trying to exclude the ones with the matching pattern. And we put a comma in here because we're trying to get the rows in here. If we do apply it after here, if we do apply the stuff after the comma, then that would be referring to the columns. But in this case, we're referring to the rows. So what this syntax means is take the stats data and remove any rows that contain alphabets in the date column of stats. So if we were to run that and we look at the stats, we can see that those rows have been removed. Wonderful. Now we can also remove any empty columns. So I know, for instance, we have an empty column over here that's unnecessary. So we can go ahead and remove that. And the syntax is very simple. So it'd be remove empty columns, or empty columns, or basically, columns without a header. So stats is going to equal to stats, where now that we're referring to a column, we're going to put the stuff on the other side of the comma. So we're going to say same thing, rep, where the pattern here starts with and finishes with. So that's how you do an empty string, is like this indicates the start of the string and this indicates the end of the string. Whoops. So in that case, that indicates an empty string. And then we can go ahead and say call names of stats. And what this means is it's going to take the stats data and remove any of the columns that have an empty heading, since this is the empty string and it's checking for the empty string within the column names of the stats table. So we'll run that, and if you're going to notice, we actually don't have that column anymore. Wonderful. Now, one problem that we have here in our data is that we have the passing yards column, but then we also have another passing yards column, and this can be a problem because you can't have two columns with the same name because it's going to cause some confusion. So how do we deal with this? One way we can deal with this, and since this is the only instance where the passing yards passing yards is duplicated, what we can do is we can write a very simple if statement that is going to check and see if a column is duplicated, and if it's duplicated, add the number 2 to the end of the other column header so that you can create some type of differentiation. So what we're going to do is we are going to check for the duplicate columns, and then what we're going to do is we are going to create an object called dup index, and we're going to set it equal to grep true duplicated call names stats. So what this does is it will return all of the column names that satisfy this condition, which basically states that return to me all the duplicated columns where they display as true. So the duplicated is a good way of checking whether columns are duplicated, or even any things in a list are duplicated. If you run that, you're going to see that for column 19 or for item 19, there is a true. So that means that it is duplicated. So we're going to go ahead and store that in there. And if we were to look at the dup index, we will see that it is 19. So good. So now we can write our if statement. So if we say if the length of dup index is equal to 0, we would want to break out of the loop or break out of the if statement. Else, we want to say set the call names of stats of the duplicated index. So what this does is it basically translates into get me the column name from the stats table of index 19. So this should return passing yards. So you're going to take that, and when it says passing yards, not to confuse it for this one over here, we are considering this one. So we're going to take that one, and we are going to rename it to where it says call names stats of dup index, and we are going to add the number 2, and we're going to separate it with an underscore. So if we were to go ahead and run all of this code over here, no loop. Okay. Yeah, I don't think we can. So I guess we just want to leave this blank and just say print nothing here. So, okay, we can just run this. Nothing here. Okay, it printed that. And then we can look at the passing yards. And the passing yard seems like it hasn't changed. Let me see if I've done anything wrong with my code. The dup index. Okay. So if we look at the length of dup index, it's equal to 1. Okay. So since this is equal to 1, it should be fine. Huh. That is a little bit strange. Okay. So I guess we don't, I guess since this is only 1, we can just set it equal to, since this is, if it's equal to 1, so I guess we could just keep it this way if we were to run this. And you can see that it's been updated to passing yards 2. Okay. So since this is the only case where we have just one duplicate of this, this is the safe way to go, but if you have a list of it, then maybe you should loop through it. But I don't know why it's giving me columns, so I'll just call this change to different name. Okay. And now let's go ahead and see what else needs some cleaning. So we have this data over here. Now, one of the things that I've noticed is that in Tom Brady's beginning season, he had a lot of instances where he just didn't play or wasn't active. So we have a lot of inactive values in here. And this is primarily based on the GS column, and the GS column represents games started. So we have the status of him in this column. So this tells us the status, whether he's inactive or whether he did not play. If it's empty, that means that he didn't start the game. He played, but he didn't start the game. Same with this instance here. And if there's an asterisk, that means he did start the game. And I believe there's another, there's injured reserve. So injured reserve means he did not play the game, of course. And then there was an instance where he was suspended for 4 games back in 2016. So we want to basically be able to recode this GS to properly show the values. So instead of showing an asterisk, I want to say that, started the game, and wherever it's empty, to say played but did not start the game. So how can we go ahead and do that? Very simple. We can say replace the GS values, and we can say stats GS, and we're going to set that equal to stats GS, and we're going to pipe it, and we're going to say STS replace all. And we want to replace all the instances where there's an asterisk, and we want to replace that with started, because that means that he started the game. And then we also want to do another instance of replacing and say replace all, where if it's an empty string, and remember how to do the empty string, we just start it with a caret and then put in a $sign to indicate that it's an empty string, to say played but not started. Okay. So if we were to run all of that, we will get an updated GS column to where we want it to look like. Perfect. Okay. Now let's go ahead, and we want to get rid of these values, of course. Now, of course, if these inactive or did not play, we just want to show a bunch of NAs. That's what we want to do. So ideally speaking, how do we go about that? So we want to take all of the columns that are after the GS column, and if it shows text in it, just go ahead and replace it with NAs. How do we go about that? So replace all columns after GS with NAs if player has not played. Okay, so first of all, we want to find the index of the GS column. So in order to do that, we can use the grep function, and the grep function is going to return the index for us. So the way the grep function works, of course, is you have to provide it with a pattern. So our pattern here is that it starts with a GS and it ends right here. So we find an exact match of the column. And then our second argument is the X, which is in this case going to be our column names, which is stats. And then what we want to do is, once we have that, we want to press enter. And the GS index should be whatever the GS index is here. So in this case, it would be 10. So if we were to go ahead and print that, it would be 10. And now what we want to do is we want to create a loop, a very simple loop. It's just a 1-line loop that will go ahead and loop through all the columns that are after GS and change all the values that have text that is in part of this text to equal to 0. So what we want to say is we want to say for I in GS index plus 1. So that's because we want to start from column 11 and not from column 10. And then we want to also go all the way till the end of the data. So we want to say endCall stats. And then what we want to do is we want to create our 1-line loop over here, which is going to refer to the specific column. So the syntax here is a little bit strange, but bear with me as I will explain it. And then we're going to put an in, and we're going to put a unique stats GS. Okay. So, and then we're going to set that equal to NA. So what this means is we're taking, so let's say the first value is going to be an 11. So it's going to say stats 11. So let's say we set the I equals to 11 over here for this example. So if we say stats right here, it's going to pull all the values from column 11, which is right here, the passing comp. And this part right over here, it's going to say within this column, give me the values that are in the stats GS column. So for column 11, return to me the values that are present in the GS. So for the GS, if we look at, we specifically did unique GS because we don't want all the values. We just want the unique instances. So if we look at, for example, unique stats GS, it's going to return inactive, did not play, played, suspended, injured, and started. So if it includes any of these, change them to an NA. And the reason why we want to do that is because in the instances that he does play, it only includes numbers. So those are the values that we want to keep. But for the values that have these, like the text, we want to remove them and replace them with NAs. So this is what this syntax means. It looks a little bit intimidating, but if you look at it a little bit carefully, it should make sense. So basically it's taking that column, and then within that column, return to me all the values of column, that specified column, that are in the stats GS column, and set that equal to NA. So that's the syntax here. It's a very simple loop. So if you run it, it says 51 does not exist. There are only 50 columns. Okay. Columns, can't subset columns that do not exist. Okay. So we have another problem that we're running into. Okay. Well, it looks like it renamed all of them. I think it went beyond for whatever reason, but it went ahead and it took care of the instances that we're concerned with. So I don't know why they are talking about. It could be that this right here is 50. Okay. That's a little bit strange, but it did work. I don't know why that happened in particular. If we were to try and run that again, yeah, there are 50 columns. That's really strange. Okay. Well, we do have 50 columns, and it did work out just fine. It did replace them. I guess it tried to do an extra column, and then it just didn't work out because that column does not exist. But in that case, it did take care of the columns that we needed to take care of. Okay, and then that's it for the cleaning. I believe it took care of all the cleaning over here. And basically what we want to do is we want to apply this same thing to the other data set. So the best thing to do is to just create a function off of these steps because we want to apply this to that other data set. So in another case, we're just going to say return. Or wait, before the return, let's just enclose all of this in a function. So I'm just going to highlight all of this right here. Let's take this, and I'm just going to tab all of this, and then I'm going to create a function, and I'm going to call it data cleaning. So data cleaning function, and the function will take a stats argument, and then I'm going to enclose this in squiggly brackets. But also at the end, I want it to return the data set itself because I'm going to set that to an object. So what I'm going to do here is, just for the sake of this, I'm going to run the stats again, and I'm going to run the stats playoffs again. So now the stats is back to the way it was before. And what I'm going to do is I'm going to create a stats regular object, which I'm going to set it equal to the data cleaning of stats. That's what I'm going to do. And then I'm also going to say stats playoffs, and we're going to set that equal to data cleaning stats playoffs. So it should take care of the data cleaning for both of them. So if we were to run this, could not find function data cleaning. Oh, obviously we do have to run the function. Yes. And then now we'll go ahead and run it. Okay, we have that. We had that problem again. So stats regular. Okay, can't subset columns that don't exist. I need to see what the issue is with this right here because I wasn't running into this before. Let me see. GS index. Okay. Let me try and run this again. And this is a part of programming where you always are going to run into errors. So if we look at the number of columns of stats, okay, so we get 51. So in this case, let's look at so if we were to look at GS index, okay, let's just take the stats argument and let's just run these and see if it's giving us any errors. Okay, that's good. It's not giving us any errors. So if we look at the GS index, it's going to be 10. So GS index plus 1, it's got to be 11. So we start at 11. So I'm just going to say GS index. I'm just going to do the calculation over here, equals to GS index plus 1. I'm going to set that, okay. Oops. Okay. And then let's just go ahead and replace this, take this out. So if we were to look at this right here, and we run this, it's going to run 11, 12, 13, 14, 15. Okay, so now it should work right now. I believe that was the problem of having that plus 1. It was confusing the loop. So let's just go ahead and rerun this again. Okay, let's go ahead and run this. Okay, the function worked out just fine. Let's go ahead and clean up the data. Okay, so now it works just fine. And now if we clean up the stats playoffs, also just fine. So now the stats, well, no, now we actually stored it in a different object called stats regular. And if we look at the stats playoffs, they're both cleaned up right now. So because it's both applicable. Now let's go ahead and solve the problem of them having different numbers of columns. So if you remember, the number of columns in the stats regular was 50. And then the number of columns in the stats playoffs was different. It's 43. It used to be 44, but because we removed that blank column, so now it became 43. But they're different. So how are we going to bind the data sets if they have a different number of columns? So this is a problem that we need to solve. So in order to do that, what we're going to do is we're going to create a list containing all the column names from the stats regular table and then all the column names from the stats playoffs and creating a unique list. So we're only going to contain the unique values. So we're going to go ahead and do that. So we're going to say all column names. So we're going to say combine all column names. And then we're going to call this, for example, all column names. And we're going to set that equal to, we're going to put it in a vector, and we're going to say call names of stats regular. And then we're also going to say call names of stats playoffs. And then we want to make sure that we are taking the unique values. So if we were to run that and we look at the all column names, it's going to return all of the names that are unique from this combination. So what we want to do here is the logic behind doing this is we want to be able to find the names from the stats playoffs that are not in the, or sorry, what we want to do, sorry, that sounds confusing. I'll go ahead and re-clarify. So what we want to do is we want to take in all the column names here, and we want to find the names that are not present in the stats playoffs header. The reason being is because the stats playoffs player has 7 columns less, and we want to know what those columns are. So usually when we're trying to check for what's in a list, we use the in. We use the in function, which is the %, in %, that we used over here. But what is the opposite of that? And that's where the negate function comes into place. So what we want to do is we want to create our own little function called NotIn. So it would be a %NotIn%. So how do we do that? So we're going to use the tick marks over here, which are located below your escape key. And we're going to say %NotIn, and then another %. And we're going to set that equal to negate. And what we're going to negate, we are going to negate the in, the %in function. So we're going to say %in. So what the negate function does is it nullifies whatever you pass in here. So since it's nullifying the in function, that means in this context, it's just going to do the opposite of it. So if you were to supply this right here, within over here, it's just going to say, give me the stuff that's not in the list. So if we were to run that, and then now let's go ahead and use it. So now let's just say, find the columns that are not in the stats playoffs, in the stat playoffs data set. So we want to call this not in headers, and we're going to set that equal to all column names that are not in, so we want to use the %sign, not in %sign, and we want to say column names of stats playoffs. So what that means is, just to reiterate the explanation of the not in, just so that it's not confusing, what this statement says is look through the all columns list and find the ones that are not in the column names of the stats playoffs dataset. Okay, so if we were to run that, and if we try to print out the not in headers, it's going to print out a bunch of true and false values. So wherever it says true, that means that that specific column is not in the dataset. So for this one in all column names, if we're looking at the true value here, we're looking at 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So if we look at if we look at all column names, 26, we're going to see receiving target. And if we go into the stats playoffs, we are not going to find the receiving target column in there. There is no receiving target. So this right here gives us all those values. So whichever ones are true are the ones that do not exist in the stats playoffs table. So what we're going to do is the logic behind doing this is we want to create those columns. If they're missing, we want to create those columns in that data set, but we want to set the values equals to 0 because there's just no data on them. So what we're going to do is we are going to find those missing columns, and we're going to create new columns based off of that. So we're going to say find the missing columns and create them in the stats playoffs data. Okay, so what we're going to do is we're going to create a new object called missing calls, which represents missing columns, and we're going to set that equal to the unique of all column names, and then we're going to set that not in headers. So what this does is it's going to return all the unique values of all the column names. Well, I don't believe we need to even use unique over here. That's redundant. So it's just going to say all column. What this is going to do is it's going to return all the values in the all column names list or vector that have true for not in headers. So if we were to run that, and if we were to print missing calls, we're going to see these are the columns that are not in the stats playoffs dataset, but are in the stats regular dataset. Okay. So now what we want to do with that is we just simply want to set those values equal to 0. So we want to create those columns and set them to equal to 0. So in order to create columns, we're just going to say stats playoffs. And since we're referring to a column, we're going to open a bracket and we're going to place everything after the comma. So before the comma is for the rows, after the comma is for the columns. And we're just going to set that equal to missing calls. And we're going to set that equals to 0. So the logic behind this is it's going to go into the stats playoffs dataset and create these new columns. So since they're non-existent and we're passing in these headers, we're passing in these strings that are not even columns, it's going to create columns and it's going to initiate those values to 0. So if we were to run that and we look into the stats playoffs, we can see that it's created those columns and it sets them to 0. Okay. So now that we have that in place, now we can go ahead and bind our datasets finally. So we can finally bind our datasets to create a master set, because now we can create a combined dataset which includes the regular season games and the playoff games. So we want to do that by saying stats combined. We're going to create a new dataset called stats combined, and we're going to set that equal to our bind stats and then stats playoffs. Okay. So once we do that, okay. Oh, very important. We need to actually order the data because it's not in the same order. So if you notice the columns, they're not necessarily in the same order. So the way we order data sets, and this is a very important step, we need to order the data sets. We can order the data sets based on a vector. So we created a vector over here equaling to all column names. So we can actually order both data sets based on that vector. And the way to do it is we just say stats regular. And then what we want to do is we want to just set it equal to stats regular. and then we're just going to say all column names. And we want to do the same thing for the other data set, for the playoffs one. All right, so let's run that, and let's run that. So now it should be in the same order. So if we were to bind these, oh, it still doesn't work. Okay, never mind. I think we need to put in a comma here. Okay, let's go ahead and run that. And let's run that. And now let's run this. Okay, number of columns of arguments do not match. Okay, let's look at the number of columns in the stats, stats regular, 50, and then stats playoffs, 50. Huh, that's very strange. Okay, let's look into the data and see what's wrong with it. Stats playoffs, stats regular. Okay. Oh, I was using stats. My bad. It's supposed to be stats regular. So if we were to run that, okay. So now it should be good. So stats combined, now it should be good. And it's good that I'm running into these errors just to show that it actually happens all the time. So just to make this as a natural process as much as possible. So we have our data combined. The only issue here is when we look at our combined data, we have all the data for all the seasons here, and then we have all the playoff data all the way at the bottom, and we want to kind of group them based on year, and that's very easy to do. We can just use the arrange function, so we can say arrange the data based on year, and all we need to do is say stats combined equals to arrange of stats combined, and then we're doing it based on year. And I believe the year is capital. Yes, it is. So if we were to run that and we look at the stats combined, now it should be combined to just show by all the years together. So yep, that looks like what we need. And then finally, we can just simply write our data set to a file. So we're going to say write our data set to a file, and then we can just simply say write.csv. And then we'll pass in our combined data set, so stats combined, and then we want to call it, for example, scraped Tom Brady stats.csv. We want to set the NAs to be blank in our file, so set that equal to blank. And then we want to also disable the row names, so set the row names equal to false. And if we run that and go to our working directory, so if we go ahead into our working directory, it should be the Tom Brady stats and scrape Tom Brady stats. Is it in there? Let's see if it's actually in there. Tom Brady stats. So it should be in there. Okay. So write.csv, scraped Tom Brady stats.csv. So I did run that. Okay. So let me go ahead and refresh that. Oh, I think that's the file right there that I was referring to. My bad. And there you go. You have the scraped data. I was confused with another file because I had run through this exercise before, so I thought it was the previous one, but it is the one. So here you go with the data. You have it all together matched up. Now, of course, you could do further tidying and further cleaning with this, but again, I'll leave that up to you. Maybe we can do this in our step 2 when we're doing our analysis, so we can do a bunch of transformation. So I know, for example, for the result column, maybe we can split this into like different columns, like a result saying win or loss or draw, and then we can put the score of the home team and then the score of the away team, and then we can kind of do a point difference. So I think that could be pretty cool. But I believe this concludes the video. Thank you so much for watching. I do appreciate you keeping up with the video. I just wanted to show you a real case scenario of web scraping and the struggles that you might face. And this is, as you can see, this has been a little bit of a struggle for me, but we're able to get some clean, tidy data with a couple of lines of code. So thank you so much for watching, and please be on the lookout for any of my future videos regarding web scraping and R Selenium and a bunch of other stuff with analytics and career development. I hope to keep making videos soon, and if you have any questions or any feedback, please leave a comment below. Thank you for watching, and we'll see you in the next video.